Welcome to Manifested Publishers.
Welcome learners, my name is Stephen Kariungi, and today we continue with our topic of discussion, and the topic is acids, bases and indicators. So today we are going to discuss the second property of acids, and this is the reaction of dilute acids with metal carbonates and hydrogen carbonates. So number two, reaction of dilute acids with metal carbonates and hydrogen carbonates. So the first property we had seen earlier was the reaction of dilute acids with metals, pure metals. But now we are going to look at how do the acids react with metal carbonates and hydrogen carbonates. And first of all, we can say that dilute acids react with metal carbonates, carbonates such as sodium carbonate, calcium carbonate, zinc carbonate, etc. and hydrogen carbonates. Hydrogen carbonates are things like sodium hydrogen carbonate, potassium hydrogen carbonate. So reacts with the hydrogen carbonates to form a salt. A salt must be there. We saw that before. There is also carbon 4 oxide. This one was not there before in the other property, and water. So we form three products here: salt, carbon 4 oxide and water. In the case of the previous property, we were getting only a salt and hydrogen gas. So also here, effervescence is observed because carbon 4 oxide is a gas. So you can say that effervescence is observed due to evolution or production of carbon 4 oxide gas. Effervescence is observed due to evolution of carbon 4 oxide gas. So you'll have an illustration of that. So we have a diagram showing the reaction of zinc carbonate with dilute hydrochloric acid, and the reaction is taking place. Then we are connecting a delivery tube that is going into another test tube that contains lime water. So lime water is also known as calcium hydroxide solution. So first of all, we are saying that in this reaction, effervescence will be observed because there will be formation of carbon 4 oxide gas here. So just to explain here, we can say that observations: one, there will be effervescence. There will be effervescence, bubbling, and this is due to evolution of carbon 4 oxide. And number two, the lime water or the calcium hydroxide solution forms a white precipitate. It becomes white from colorless. So lime water forms a white precipitate. Forms a white precipitate that dissolves later. So we'll have an explanation of that. Let us explain those observations explanations. So we are saying one, effervescence is due to evolution or production of carbon 4 oxide. So let us write the equation. We are saying that zinc carbonate plus hydrochloric acid will get three products. We'll get zinc chloride, which is a salt, plus carbon 4 oxide, which is a gas, plus water. This is what we have mentioned. We form a salt, carbon 4 oxide, and water. So the salt is zinc chloride because it's zinc, then hydrochloric acid, zinc chloride. Carbon 4 oxide from the carbonate, and then water. So that is why there is effervescence. Explanation number 2 is that when carbon 4 oxide is bubbled into lime water, it forms a white precipitate. So the white precipitate will be observed here in the second. So lime water is clear, but after some time it forms a white cloudy precipitate. And the reason for that is because the carbon 4 oxide combines with the lime water. Lime water, we have said, is calcium hydroxide. So here you get calcium carbonate. Plus water. So this is the white precipitate. The white PPT is calcium carbonate. So we have explained the two observations: effervescence due to carbon 4 oxide. Lime water forms a white precipitate because carbon 4 oxide combines with the lime water to form calcium carbonate, which is a white precipitate. There will still be a third observation, or the third explanation. There will be the third explanation because we are saying that the white precipitate dissolves later. Why does it dissolve? Is that number 3, calcium carbonate precipitate reacts with excess carbon 4 oxide, to form a colorless solution. Of calcium So we are saying that calcium carbonate precipitate that has formed in this test tube, it reacts with excess carbon 4 oxide that is coming from here to form a colorless solution. It becomes colorless due to the formation of calcium hydrogen carbonate. So we are saying that, so we have this calcium carbonate, plus water. Those were the products. Then you add excess plus carbon 4 oxide. This is now the excess. So we form calcium hydrogen carbonate, which is colorless. So we are saying that that is why the white precipitate or the white cloudy substance, when you add excess carbon 4 oxide, it is dissolving because of the formation of calcium hydrogen carbonate solution. So there are 3 explanations. 1, effervescence, because there is carbon 4 oxide being produced. 2, there is the carbon 4 oxide reacts with the lime water, which is calcium hydroxide, to form a white precipitate. That is the second one. The third, the white precipitate reacts with excess carbon 4 oxide to form a colorless solution. So it therefore dissolves. So that is as far as the explanations for that experiment is concerned. So the observations: effervescence, the bubbling is there. These are gas being produced. Lime water forms a white precipitate. It was initially clear. Then the white precipitate, after some time, it dissolves. And we have explained all those observations. So the first question, explain why A, lime water forms a white precipitate when carbon 4 oxide is added, or when the carbon 4 oxide is bubbled. B, the white precipitate dissolves later. Number 2, write a chemical equation between the reaction of zinc carbonate and dilute hydrochloric acid. So you write the equation for that. So we're going to stop there. Until the next time, goodbye.